These are the problems on torque and potential energy of dipole. This system we already discussed in some previous classes. Let me brief about it again. Just a brief note of it. The system is electric dipole is placed in the electric field. Electric field is uniform. Electric field is uniform. Electric field and the dipole, electric dipole is, as you know, there are two charges which are separated by or linking by this the distance of 2L, and this Q is called magnitude of the charge. It remains same on both sides, but only carrying one is negative charge, other is positive charge. That is the only difference. So this electric dipole is placed in the electric field. What happens? Uniform electric field. Uniform electric field means that is electric field strength is remains same at all points in the space. So electric field electric field at this point remains same. Electric field intensity. So due to the same electric field and the charge they carry, they exert a force. What is the force? Equal amount of force, equal forces of equal magnitude, but the directions are different, opposite direction. It is because of one is carrying positive charge, other is carrying negative charge. So positive charge means this is the direction, negative charge means this is the direction. If that is the case, what happens? Two forces which are acting in the opposite direction of same magnitude. If that is there, what happens? So it produces a torque effect. What is a torque effect? It produces, so it is angular momentum, not linear momentum. Angular rotation of the dipole. So that will cause a rotation of the dipole. So force, the torque means the force which causes the rotation of a dipole. Rotation is called as torque. The torque, it is a result of these two couple of forces. So that only torque is observable in uniform electric field. Uniform electric field. If the field is non-uniform, then the non-uniform is at different point you are different field intensity. Here we have different electric field. So due to difference in electric field, the forces are different. The forces will be different. So we have no equal forces, unequal forces and opposite direction. That is unequal forces. What is this? Create or results in a net force on this dipole. So any net force on the object will cause displacement. So in non-uniform electric field, where the electric field has no homogeneity, if that is the case, we see that we have both effect, that is a displacement effect and angular effect. That is a displacement and as well as torque in non-uniform electric field. So dealing with both these is a little bit complicated. That is, it is not a subject of our study. The subject of our study is only torque. So torque is only torque is produced in uniform electric field. The magnitude of torque what is produced here is given by this equation P sin theta. The magnitude of torque is P sin theta. Here remember this equation. This equation we have derived it in the previous classes. Remember this equation. The torque, what is a measure of force which rotate this dipole, it is given by P sin theta. P means it is the magnitude of dipole moment of this dipole, and magnitude of electric field, and theta is the angle between theta is the angle between this line and this line. This line is the axis of dipole, this line is norm, that is parallel to the electric field. So this dotted line, and there is one more dotted line. This line is perpendicular to the electric field, this line is parallel to the electric field. As a reference lines in the electric field are written and passing through the center of the dipole. So PE sin theta, that is the one. So due to this interaction between the dipole and the electric field, we see there are two effects. One is the torque effect and energy effect. Energy is potential energy of the system. So we have also derived the potential equation for potential energy as U is equal to P into cos theta 1 minus cos theta 2. Recall this equation. So this potential energy, now look here. It appears in the system when there is a rotation from one angle to other angle, that is angle theta 1 to angle theta 2, initial angle and final angle. So due to this rotation, what is that? Magnitude of rotation, energy, potential energy will appear in the system. So it will appear in the form of what is that, releasing from the system, or it will enter into the system and store it up. Depends on the direction of the rotation, depends on the direction of the rotation. If the rotation is clockwise, what is that? So work is done by this rotation by itself. If the dipole is rotating by itself, that is in the clockwise, work done by the system itself means rotating by itself. So that work is done at the cost of the energy. That energy is potential energy. Potential energy decreases if it rotates in the clockwise direction. Suppose if the dipole is rotating in the anti-clockwise direction, it is not rotate by itself. It requires external force or external energy, external work to rotate it. So that external work has become potential energy and store it in the system. So clockwise energy release, anti-clockwise energy storing up potential energy. So magnitude of potential energy depends on the angle between theta 1 to theta 2. Initially is theta 1. So theta 1 in all literature books, theta 1 initial value is taken as pi by 2, and theta 2 is theta, this theta, some theta value. So if theta 1 is initial value is pi by 2 and final value is some theta, let us put this into the equation and see what the equation becomes. So this equation reduces to this equation, simple equation, because cos theta 1 means when cos theta is cos pi by 2, cos pi by 2 is 0. 0 minus this is minus of this. So final equation is potential energy is equal to minus P cos theta, that is P is equal to P sin theta. So look, this expression is very important. So this says that what is the magnitude of potential energy in the system given by this equation, what is the magnitude of torque in the system given by this equation, and let us see what are the possible values, minimum and maximum values. It depends on the theta value. Let us feed the value for theta. If theta is equal to 0 into this equation, theta equals 0, theta equals 0, it becomes sin 0. Sin 0 means 0, 0 and anything is 0. If theta equals pi by 2, sin pi by 2 is 1. 1 into P is equal to PE. T equals 0 means minimum value, T equals P means maximum value. So we find that there are two minimum, least possible value is 0 torque value in this system, and highest value is P, maximum value is P in the system like this, in this rotation. So these are the possible values. Let us see what are the possible values of minimum and maximum possible values of U in the same way. Here substitute feed the value for theta when theta equals 0. So put the that is theta equals 0, cos 0 equals 1. 1 into this is minus PE. U equals minus PE when theta equals 0. What is u when theta equals pi by 2? When theta equals pi by 2, cos pi by 2 is 0. 0 into anything is 0. U equals 0. Potential energy is 0 when theta equals pi by 2. What is theta equals pi? That is 180 degree. So cos pi is 1. Cos pi is minus 1. Minus 1 into this is plus this 2. Look at this. The values oscillate. The minimum value of potential energy is this. Maximum value of this is minus value is plus value. The 0 lies in between. Lies in between. So these are the possible minimum and maximum values. Potential energy. So total potential energy that will store up in the system if you rotate from this point to this point, 0 to pi degree. Here from this point to this point is PE value, that is 1 PE. Again from this point to this point, one more PE, that is one more PE. So total amount, total potential energy stored up in the system if you rotate from here to here is 2 PE. It is same as the same amount of work done in rotating this from 0 to pi. That is the amount of work or potential energy increasing from here to here and clockwise. So these are the things I will brief. So I have briefed it again. So let us work out problems on this equation. Look at these equations. You know that this definition says cross product, this definition says dot product. Of course, this is scalar, this is vector. Let us come on solving the problem. The problem is if you know the values of P, E, theta, you can calculate what is the magnitude of torque and what is the magnitude of potential energy. That is U. That is. Now the problem is set on this. So this problem, the data is on the problem. Problem is not written. The data of the problem is taken. Data says you have to calculate what is the torque and potential energy of the system. Where the dipole charge is this and the distance of separation is this and is placed in the electric field of this length and theta is the 30 degree. Angle between this and this is 30 degree. So it is for the calculation of this, use the equation of tau. For the calculation of this, use the equation of U. So P is equal to P sin theta and P value is not given, but you substitute for P as Q into 2L. This is the one already written. Then, so with this equation we know all these values. Value of Q is given, substitute into the equation. The value of L, it is given in centimeter in meter, convert it to meter and write it. Value of P and value of theta is 30 degree. And substitute for them and solve for T. We get the sin theta is equal to sin 30 is 1 by 2. Sin 30 is 1 by 2. So when I simplify, we get what is torque. This value is the torque of the system. Unit is Newton meter. So similarly, we can do the calculation of potential energy. Use what is the difference is sin theta is there, cos theta minus is the difference. So substitute the same way. Here all these things are same. Cos theta is cos 30. Write the value of cos theta is 3 by 2 and simplify. You get this value. This value is the joules. It is the amount of potential energy in the system with this set of data. So this is how this problem is solved. The next problem is, look at this. We have two equations. If the value of torque is given, can you calculate the value of potential energy? Yes, it is possible. Write both the equations. Link them. Link these two equations. How do you link? So in this equation, write what is PE. And this is the one. Substitute for P in this equation. You get this. Then cos theta by sin theta is cos theta. See the linking. So these two becomes U equals minus T into cot theta. Look at the data of the problem. Data of the problem is you are given the value of t and value of theta. This is the value of t, this is the value of theta, cos 60. So find the cos 60 value. Cos 60 is 1 by root 3. Root 3 cancels, 4 remains, minus 4 is a joule. It is a potential energy of the system for this data. So this is how we can calculate. This is the problem is solved. Now the problem, the other problem is, this is a problem. Just the reverse of this. What is that? Here you are given t, calculate u. Now in this problem you are given u, can you calculate t? Yes, it is also possible. U value is given, theta value is given, t value can you calculate? You can calculate because use the same equation and write this equation in terms of u. That is, rewrite as this and substitute this into this equation, you get this. Sin theta by cos theta is tan theta. That is, finally we have what is that? T is equal to minus u into tan theta. So tan theta means tan 45 degrees given. Tan 45 value is 1. 8 into 1 is equal to 8. But here interestingly, what is that? We see that u value is 8 joules. U and t value remains same because the angle is 45 degree. So this is what says that if this value is given, this value can be calculated. But in the problem, we have one more. Calculate the magnitude of the charge and the dipole. Given this electric field and the distance of separation of the two charges. You can use any one of the equations like this. Any one of the equations. T is equal to P sin theta. P value, that is substitute for P, Q into 2L. Here substitute for them in this equation. This value is calculated. Write this value. This value is not known, write it as it is. This value is given in centimeter, write it in meter. Assign it. This value is given and value of theta is given sin 45. And solve for Q. Q is equal to this. Sin 45 value is 1 by root 2. Put this and simplify, we get this value. This value is what is that? 0.2828 coulomb. It is the magnitude of charge on the dipole. This is what the problem is. This is how you can solve this problem for this data of the problem. So last problem is the data is given here. The dipole moment of the dipole is given, that is coulomb meter, and torque of the dipole is given, and theta value is given. You are supposed to calculate what is the electric field strength of the field in which this dipole is placed, and also potential energy of the system. So write the equation, because T is given, write the T equation. So T is equal to this. So write, substitute for T and substitute for P value is given. By value of T is not known, write it as it is. Sin theta value is sin 90, and solve for E is equal to this. Sin 90 is 1. Sin 90 is 1. So simplify this, get now what is the value? E value get Newton per coulomb. That is the intensity of the electric field in which this dipole is placed. And also you have to calculate one more, potential energy of the system. So what is the potential of the system? U is equal to minus P cos theta. See that what is theta value? Theta value is 90 degree. As you know, sin 90 is 0. 0 and everything is 0. So potential energy of this system is 0. Here value is calculated as 0. This value is this. So this is how this problem is solved for this data of the problem. Remember, the most important thing is only thing, you have to remember these equations. That is, what is the torque? Pe sin theta. What is the potential energy? Pe cos theta minus Pe cos theta. Knowing these equations, we can solve any set of problems on this. So taking what is that? The technique of solving or steps of solving, only mathematical technique. So this is how we can solve the problems like this in this chapter. Thank you very much.